Hello, welcome to the third lecture on representing data. Our learning outcome is to interpret frequency tables and grouped data tables. So let's consider some data. Students were asked how many cousins did they have, and here were the answers. 2, 3, 5, 0, and so on. But this isn't easy to interpret. It would be better if we could organise the data. Now, if we are interested in counting how many times each value occurs, then we can organise the data into a frequency table. And here is the frequency table for our data. We can see that one student had 0 cousins, 2 students had 1 cousin, 5 students had 2 cousins, and so on. Sometimes it's useful to know which data value occurred the most often. Now, from our table, we can see that the highest frequency of students is 5. So this means that the most frequently occurring number of cousins is 2. Now, it may also be useful to know, for example, how many students had less than 4 cousins. To do this, we add a column to our table, and this column is called the cumulative frequency. So how do we calculate cumulative frequency? It's a running total of the frequencies. So we started off with 1 student, so our cumulative frequency starts at 1. And then we say the 1 plus 2 students from the next class. 1 plus 2 is 3. Then we'll do the 3 plus the 5 from the next class, and that gives us 8. Then 8 plus the 1 equals 9, and we continue in this fashion until we have completed all of the rows. And this is useful because we can see at the end our total number of students is in fact 15. Now we can also group data together, and here is a grouped frequency table. This table shows the lengths to the nearest millimetre of 30 rods, and each group is called a class. But are all the classes the same size? Well, to calculate the class width, we need to know the class boundaries. And there are various methods for how to decide upon the class boundaries. So you will see different answers in different textbooks. So let's decide how we are going to do it. And we will decide the class boundaries depending upon whether our data has got gaps between the classes. Let's look at 2 examples to show you how to do this, how to decide the class boundaries, and then how to calculate the class width, and also the class midpoint. So here's the first example. It's the grouped frequency table we had previously. And we can see that there are gaps between our classes. We jump from 31 to 32. There is a gap. When we do have gaps between the classes, then we use the middle value between the gaps as the class boundaries. So we can see that the middle value between 31 and 32 is actually 31.5. So 31.5 will be our upper boundary for the first class and the lower boundary for the second class. And similarly, the gap between 36 and 37, halfway, is 36.5. So we'll use 36.5 as the upper boundary for the second class and 36.5 as the lower boundary for the third class. And you can see we have 46.5 calculated in the same way. Now the first lower boundary and the last upper boundary, that's 26.5 and 51.5, for consistency, then we just use the 0.5 values as we have done for the remaining boundaries. So for the first one, for 27, we use 26.5, and for 51, the last boundary, we use 51.5. Okay, so that's the lower and the upper boundary. So now we need the class width. And the class width is very simple. It is the upper boundary minus the lower boundary. So what we have here is 31.5 minus 26.5 equals 5. And 36.5 minus 31.5 also equals 5, but 46.5 minus 36.5 equals 10, and our last class, 51.5 minus 46.5 equals 5. So that's the class width. It's also useful to know the middle point of the class, called the midpoint. And this is simply the mean value between the boundaries. So the mean value means we add the values together, lower boundary plus upper boundary, and then divide it by how many we have. We have 2, so we will divide by 2. So we can see that for the first class, lower boundary plus upper boundary, 26.5 plus 31.5, divide it by 2, and we get 29. And similarly for the rest of the classes, let's do the last one, 46.5 plus 51.5, divide it by 2, does equal 49. So we have our class midpoints. One special note to consider is when we do have gaps, but our first class starts with a 0, as we do here. Now this is a length, and usually you would think a length cannot take a negative value. But for consistency, when we choose our first lower boundary, then we do use a negative value. We actually use minus 0.5, because the other boundaries all have 0.5s. Between 5 and 6, the midpoint is 5.5. Between 10 and 11, we have 10.5. Between 20 and 21, we have 20.5. So for consistency, we do use minus 0.5. So for this first class width and first midpoint, be careful, because our class width, upper boundary minus lower boundary, becomes 5.5 plus 6.5 to equal 6. And then our class midpoint, 5.5 plus minus 0.5, divided by 2. So 5 divided by 2 is 2.5. So just be careful when your first class starts with 0. And our second example is when we have no gaps between the classes. This is much simpler. We simply use the numbers from the classes as our boundary values. So in this first case, our class is 0 to 3, and that's exactly what we use. Lower boundary of 0, upper boundary of 3. We have no gaps. Our next class starts at 3, the same value as the previous class is upper boundary, and we have 3 to 6, so our lower boundary is 3, our upper boundary is 6, and so on. Much simpler. Class width is the same, upper boundary minus lower boundary, so we'll have 3 minus 0 equals 3, 6 minus 3 equals 3, and so on. In fact, all of the class widths are 3 in this case. Class midpoint, remember, we want to add the, let me just change my colour, add the boundaries together and divide it by 2. 0 plus 3 is 3, divided by 2 is 1.5. And the last one, 9 plus 12 Can I do that? 9 plus 12 is 21. Divided by 2 gives us 10.5. So in summary, cumulative frequency is the running total. Each group is called a class. The class boundaries depend upon whether there are gaps between the classes. If there are gaps, then use the middle values between the gaps. Class width equals upper boundary minus lowest boundary, and class midpoint is the mean of the lower and upper boundary, so that's lower boundary plus upper boundary divided by 2. Now try the question.